All right, this is your lab format, okay, for any of the labs that you're doing in this class. Very first thing I want to address is going to be your notebook itself. Okay, you're in a quadrile notebook or a graph paper notebook, and you're only going to write on the right pages. You are not going to write on the left and right pages like you do with your other notebook. So only the right pages, which means that when you open up your notebook, that right page is your cover page. Okay, make sure your cover page has your name, the period, and then the year. Okay, uh, the and it's important that we are in pen only and blue or black pen only. So blue, black pen, only right pages. Okay, and page one is the cover page, name, period, and year. Your pages 2 and 3, which are the next two right pages, those are your table of contents. Okay, because you're just going to number um, all your pages throughout. Okay, and we'll just have the same numbers, and you'll always refer back to your table of contents in order to see where your next lab is. Okay, so the first lab that you're going to do, which is your dissolution lab, that is going to be on page 4, right? Now this, what you see on your screen right now, is your lab format. Okay, very first thing I want to discuss, however, is your header, which is this guy right here. Okay, at the top of every right page, I want your last name, and then the lab abbreviation, one word. Okay, one word abbreviation. I'll tell you what that word is for your first lab, your dissolution lab. The word is dissolution. And then under that, the page number. You don't have to write page and the number, just the number is fine. Okay, so your header, name or last name, abbreviation, and then page number. All right. So with that said, let's go ahead and go to your format. Every lab must have a title and a date. Okay, title and date. That only needs to go on the first page of your lab. It does not need to go on every page. Only the header stuff goes on every page. If you have your header on every single page, that automatically, okay, the header on every page, and you have a title and date on the very first page of your lab, that is going to be not 50, 5% of your notebook of your lab score. Okay, if you don't do that stuff, you automatically get a 5% deduction. All right, now let's go ahead and take a look at the other stuff that is going to be in your lab. Your observation and question. Okay, both of those, they need to be written. Okay, remember, all blue or black ink. Write your observation. Your observation may also be considered a problem. Okay, but it'll either be observation or problem. They could be either one. That's 2%. So write that in there. You automatically get 2%. Next is your question. That is also 2%. After that, the hypothesis that you formulated, which is the answer to your question, is 4%. The prediction, the if-then statement that coincides with your hypothesis to answer the question, which also that prediction hints as to what you're going to do in the lab, that is 4% as well. Now, your procedure, which goes after your prediction, is going to be 10% if you have a graph if you have a, remember, there's two types of labs. There's quantitative and qualitative. If you have a quantitative lab, that means there's going to be graphs, and this format that you see right here is going to reflect as if you had graphs. So 10% is if you have a graph. It's going to be, your procedure is going to be 15% if you don't have graph. All right. After that procedure, you're going to have your your independent variable and your dependent variables. Just list them out. They don't need to be in complete sentences. Just say independent variable, colon, and then this is it. Okay, and the same thing with your dependent variable. After that, I want you to see your raw data. These are the calculations and the work that you need to show. Now, this is not Scratch. This is not like scratch paper. This is the work that you did neatly written out. So I can see if I really wanted to look, okay, to see what steps you made. For the most part, your raw data, I am not looking at it. I'm going to look for it just to make sure that it's there, okay? But if I see some big mistakes in your data table, then it's nice to have that raw data so I can go back and look to see where you got some of these numbers, okay? Speaking of data tables, that's going to be next, okay? Usually the data tables I'll have for you, all you have to do is just fill them out. but there will be times where you'll have to make your own data tables. Okay, your data tables are going to be 5% of your lab if you do not have, if you have a graph, but it's going to be 10% if you don't have a graph, because I have to make up for that extra 15%, which your graphs are going to make up. So if you do have a graph, like you will in the dissolution lab, okay, and I'll show you which types of graphs you need to do for that dissolution lab in this example, because this graph does show me both both types of graphs that you're going to do in this class. Okay, so that'll be your graphs, and then you'll also have after that you have your data analysis, which, as you can tell, is the biggest chunk of everything. Okay, if you have a graph in your lab, that's going to be 35% of your lab. If you do not have a graph, it's going to be 40% of your lab. Either way, big percentage. Okay, and then lastly you have your conclusion. Okay, and remember, your conclusion is only one of two sentences. Remember, it is going to be if the data supports the hypothesis, the data rejects the hypothesis, or the data does not reject the hypothesis. There is no supporting going on. It's either rejected or not rejected. Okay, now as far as how these are supposed to be written out, this is the order they're supposed to be written out, but what I would like is in between each one, okay, I would like you to leave a space. So skip one line. Now, since this is written in graph paper, that's not going to be very big of a line. But yeah, I want you to skip a line in between each one. Now, when you're writing your procedure and you're writing on multiple lines, because you're not going to fit your entire procedure on one line, you do not need to skip lines if it's within the same topic. So your observation, if that's one line, then that's one line. If it's two lines, then you would go two straight lines, and then you would skip a line before you go to question. So skip a line in between these different topics, all right, or these different parts of your lab. Okay, so you have your order. You know it's pen only. You know you have your table of contents. You're on the right side only, which means this lab, your dissolution lab, should go on page 4. Okay, there is no limit to how many pages you use for a lab. Okay, if you're doing your lab and you end up with observation through procedure ends up being on page 4, and then page 5 has your variables, your raw data, and your data tables, and then the last 3, the graph, the data analysis, and the conclusion, end up being on page 6, so be it. There is no structure to that. All right, it's just whatever you do, make sure it's reflected in your table of contents. Okay, so if your lab number 2 starts on page, in this case, because this is page 4, this is page 5, and then this would be page 6, you would write that lab number 2 in your table of contents would start on page 7. All right, so let's go ahead and take a look at your graphs that you're going to do for this lab, but it's also the 2 types of graphs you're going to do in this class total. All right, the first type of graph you're going to do is an XY scatter graph. Now, this could be accompanied by the connection of dots. It usually isn't, and it could be not connected, but associated with having a best fit line or a trend line, because that's pretty much what you're trying to do with an XY scatter, is discover a trend in your data. All right, so remember, it doesn't matter what type of graph it is. There's a couple things that you need to make sure you do. One, you need to label your X and Y axes. Make sure you label them and have them scaled correctly. And what I mean by that is, if this, from this point right here to this point right here, is 5, that means from this point right here to this point right here must also be 5. Because I hate it when we get things like, oh, this is 5, and then this is 27, and then this is 312, and then the real wonderful ones is when we go actually backwards as we go up a number line and go 6. Okay, so make sure, don't do that. Make sure that you have your X and Y labels or axes properly scaled when you do it. Okay, and make sure they're labeled. You do not need to label individual points. Okay, but if I do ask you to connect the dots, which, like I said, I rarely will, most likely I'll have you guys do a best fit line. And usually you will always use a straight edge when doing a best fit line. I would happily use a straight edge right now if I could get away with the smart board allowing me to use a straight edge. But I guess I can give it a shot. Hopefully I don't screw everything up. All right, so you want to get your best fit line. No, I'm surprised it didn't break something, but you'd want to choose use your straight edge to do a best fit line. In this case, you're showing a trend. In this case, with a positive slope, then we can talk about things like proportionality later. Okay, but you will have plenty of graphs in this class, and majority of them will be of the XY scatter. Like I said, axes labeled, axes properly scaled, XY scatter is looking for trends. Okay, for your first lab, for your dissolution lab, you are going to do an XY scatter lab, or XY scatter graph, but it's going to be with the rate of dissolution. Okay, your rate of dissolution is going to be on your y-axis. So for your lab, you're going to have rate of dissolution, and then on the x, you're going to have temperature. Okay, most of the time when you guys do an XY scatter graph, your dependent variable is going to be on the y-axis, your independent variable is going to be on the x-axis. Okay, it's not always going to be the case, but vast majority of the time, that's what's going to happen. Okay, so you're going to have temperature, and then you're going to have rate of dissolution. You will draw, in this case, you're going to have only two plots. Okay, you're going to have two dots to plot, and because there's only two lines, I would like you to please connect the dots for this particular lab. Okay, because that data is going to be important for your first test. So for your dissolution lab, the y-axis is your rate of dissolution, and remember, you need to include your units on your axes, milligrams per second, and temperature is in degrees Celsius. So that is your XY scatter for your first lab. Your other graph is going to be a bar graph. Okay, now a bar graph is used mainly for comparison. Okay, so XY scatter graphs are for trending, bar graphs are just for comparison. Now, the main difference is with your x-axis on your XY scatter graph, it's almost infinite. Okay, but with your bar graph, there's finite values for your x-axis. So in this case, for your dissolution lab, you only had two surface areas, because this is going to be your surface area graph right here. Okay, you had two right there. You had rock salt, which had a certain surface area, and then you also had table salt. This would be salt. This would be a properly labeled x-axis for a bar graph. Now your y is still going to be rate of dissolution in milligrams per second. Okay, so this is still your y-axis. Your y-axis didn't change, but in this case, your x-axis changed because actually I have a different independent variable right here. And of course, the rate of dissolution, here and then, okay, or whatever. The values that I put up there are irrelevant, but just make sure that you have, again, same as your XY scatter graph, you have your y-axis properly labeled and scaled, okay, and then you have your bars to show the comparison. Now, could we have made the surface area, okay, of your salt, could we have done an XY scatter graph with it? Yes, we could if we were able to actually measure the surface area of the rock salt versus the table salt. But because we didn't, we just looked at rock salt versus table salt and then did a rate from that. You're just comparing the two, so you would do a bar graph. Okay, so those are the two types of graphs that you're going to have. So when you have qualitative or quantitative data, if I'm comparing two things, I'm going to use a bar graph. If I'm trying to find a trend in the data, then I'm going to use an XY scatter graph. Okay, so for your dissolution lab, your very first lab, these are the two graphs that you're going to use. You're going to use a bar graph for the surface area portion of the or the surface area independent variable, and then for the temperature independent variable, you're going to use an XY scatter graph. Okay, if you guys have any questions, make sure you ask me when you're in class, or at lunch, or after school.